This is the crystal notch filter I have been using on 20 MHz to evaluate sideband noise in the signal produced by a frequency multiplier from 10 to 20 MHz. The power level was up to 27.5 dBm, and this filter cannot take such high powers without creating noise from the crystals. So I will increase the number of crystals and also step up the impedance level a little to make this filter adequate for high power signals. Well, high power, for an oscillator high power. The performance of the filter is like this. The notch is about 30 decibels deep, which means that notches that come after it are not critical anymore. And the impedance looks like this. It's about 2 ohms at the center of the notch. Now there are nearly twice as many crystals, so the current through each one should be about half of what it was before, means a 6 dB advantage. And then there are these ferrite transformers that step up the voltage by a factor of 2. That reduces the current by a factor of 2, which means that there is another 6 dB advantage. So this unit should now be tolerant to about 12 decibels more power than before. And here is the circuit diagram. Input, step up from 50 ohms to 400 ohms. Then a crystal with a coil in series to get the resonance frequency where I want it. And then an inductor in parallel to compensate for the capacitance through here. And then there is the other bunch of crystals which have a slightly different resonance frequency. So there is a slightly different inductor here. And then they go to a common tuning capacitor. And finally a step down by a factor of 2 of the voltage to get back to 50 ohms. The two inductors are significantly different. Well, it may be hard to see from here, but I have to tweak them to not get a double notch. Means that the notch should be on the same frequency for both groups of crystals. The notch is a little deeper than before, but not so much. But this should be an advantage, and I will check with the frequency multiplier whether it indicates a difference in performance. I'm using the same setup as in the previous Nerds video. That's with the active frequency doubler with 8 + 8 J310. And here is the level. I have calibrated it to show 0, and that is without any attenuator, because now the notch filter can handle the power. And then I switch on this reference signal and get it into the filter and check the level, and it shows -80.0. So I go over to the SDR IP where I have the same signal and I check the level, -80. So this level is 80 dB below the carrier, and I switch off that pilot tone, and here comes the noise floor at a separation of 102 kilohertz. And the bandwidth is unchanged, it's still 1 kilohertz. And the value I see now is 161.5. That means minus 191.5 dBc per Hertz. That's here, just a little bit better than before. So contribution from the test instrument degraded what I saw in the previous measurement. When running the notch at a higher impedance, it becomes much wider. So I can no longer check the noise at 5 kHz separation with a notch filter. I will have to make one more unit that is identical and then compare the two of them in the interferometer.